Such a sad news. This pair of couple must break their engagement just because both are carriers for thalassemia. We have seen many couples meet the same fate, but why is that? Let's dive in to know more. Thalassemia is first described by Thomas Cooley in 1925, and decades later, we have already found various forms of it thanks to many doctors. In short, thalassemia is an inherited blood disorder where human body fail to make healthy red blood cells due to formation of abnormal hemoglobin. Electrophoresis is used to find an abnormality in hemoglobin since different hemoglobin have different magnitude of negative charge, thus it moves at different velocity towards positive node. Thalassemia occurs most often among people of South Asian, Italian, Greek, Middle Eastern and African descent. It can be classified into two categories, which are alpha thalassemia and beta thalassemia. These two groups can be further classified according to their severity caused by gene mutation. But how thalassemia occurs? Mutation that occurs in the DNA will affect promoter sequence and splice sites, which later interfere with how mRNA is translated. First is alpha thalassemia, which is mutation in 4 genes at chromosome 16 involved in making of alpha globin protein chains. If you are missing only one gene, you are a silent carrier which you will not show any symptoms or illness. If you are missing 2 genes, you have alpha thalassemia trait, also called alpha thalassemia minor, which means you have mild symptoms of anemia. If you are missing 3 genes, you will develop thalassemia that causes moderate to severe anemia. In very rare cases, a baby is missing all 4 genes. With this condition, it's called alpha thalassemia major or hydrops fetalis. Babies who have hydrops fetalis usually die before or shortly after birth. Next, beta thalassemia is characterized when there are mutations in 2 genes at chromosome 11 involved in making beta globin protein chain. If you have one altered gene, you are a carrier, which means you have beta thalassemia trait or beta thalassemia minor. It causes mild anemia symptoms. But if you have both genes are altered, you have beta thalassemia intermedia or beta thalassemia major, also known as Cooley's anemia, which you can develop moderate or serious anemia symptoms.
Now, we are going to the interesting part of the video, Punnett square. Have you ever heard of it before? Well, basically Punnett square is a useful tool that many people use to predict the probability of offspring having a specific trait or characteristics. Before we jump to our so-called genetic lesson today, let me remind you that thalassemia is inherited in autosomal recessive manner. This suggests that you need to have both alleles for thalassemia in order to develop the disease. Taking the broken engagement case earlier in the video, for example, we started off with 2 parents. They are both heterozygous for thalassemia. It means that they only have one allele for thalassemia. So, we call them as carrier. They did not develop the disease, but can pass down the allele to their next generation. Fertilization occurs, you can see that the child will have 25% chance of developing thalassemia major, 50% of becoming a carrier, and 25% chance of having a normal health. So now, you can see why the couple decided to break off their engagement. It is because they could not bear the possibility of causing their child to develop the thalassemia. Next, we will discuss about family pedigree, which is another type of tool that can be used to trace the disease between number of generations. Thus, we can describe how the disease being inherited down the generations. When both parents are carriers of thalassemia, there is a risk of having children with thalassemia major, which is a more severe form of the condition. In a family pedigree where both parents are carriers, the notation often includes symbols representing individuals and lines indicating relationships. Here's a simplified representation. For an individual, they will be represented by a square for males or a circle for females. For thalassemia carrier, which is in heterozygous state, they will be presented by a half-feet square for males or circle for females. Lastly, for thalassemia major, which is in homozygous state, they usually represented by a fully filled square or circle. In this situation, each child inherits one allele from each parent. If both alleles inherited by a child are normal, the child will be normal. If one allele is from a carrier parent and the other from a normal parent, the child will become a carrier. And if both alleles are from carrier parents, there is a 25% chance that the child will have thalassemia major. There are several ways to treat the symptoms of thalassemia. First is blood transfusion, which involves the patient receiving injections of red blood cells through the vein to restore normal levels of healthy red blood cells and hemoglobin. Depending on the severity of the thalassemia, the patient may be receiving transfusion every 4 months or every 2 to 4 weeks in case of high severity. In Malaysia, estimated there are 2,400 thalassemia patients who receive regular packed cell transfusions 3 to 4 times weekly to alleviate the chronic anemia that associated with the disease. In this, patients might need iron chelation therapy, which is a procedure to remove excess iron in the body due to regular blood transfusion that can cause the iron to accumulate. This can be achieved by consuming iron-chelating drugs like deferriprone and deferrixirox. Drugs also have been found effective to manage the symptoms of thalassemia. For examples, hydroxyurea, 5-azacitidine, butyrates, and erythropoietin. Thalassemia is one type of disease that is difficult to be cured because it involves our gene being altered. However, with the advancement of technology, scientists and physicians, they have found some ways to completely cure this disease. Firstly, by having hematopoietic stem cell transplantation or bone marrow transplant. It is the most conventional option to cure thalassemia. It mainly involves the transfusion of thalassemia patient with normal stem cells harvested from a compatible donor. These stem cells will then repopulate and differentiated to produce healthy and normal red blood cells. If it is successful, then the patient is no longer transfusion dependent. Last but not least, the most expensive way to cure thalassemia is by doing gene therapy. This procedure involves the patient's gene being edited. CRISPR or
Clustered regularly interspaced short palindromic repeats.
is one of the gene therapy technology that can be used to edit the gene.
So, how does this fancy technology works?
Basically, the patient's mutated DNA segment will be cut out by an enzyme and the healthy segment will be inserted and replaced at the cut. The patient then will have normal functioning gene that will code for healthy red blood cells.
Now, let's move on to other life choices that can be chosen for people with thalassemia. People with thalassemia may consider to take special vaccines such as pneumococcal and meningococcal vaccines because they are considered high risk for certain infections. They may also alter their everyday diet. This is because they may have too much iron that may build up in their blood. So, foods that contain high iron must be limited and they are recommended to consult with their doctor for better diet. Am I right? They also should discuss with their doctor about their physical activities as they may have trouble doing vigorous form of exercise. On the other hand, people with thalassemia or even a carrier are subjected to make important health decisions, especially when they want to commit in romantic relationship with intention to have kids. For example, getting tested for STD, sexual transmitted diseases, or using condom. In addition, genetic counseling is recommended prior to any pregnancy if you have family history of thalassemia. This is important so that you and your partner are well informed of your risk of having a child with thalassemia. This is the end of our video. We hope that you guys learn a lot about thalassemia. Thanks for watching. Bye bye.